Hi everyone, so we are from group 5, going to present our structure analysis for static, and I am Muhammad Afiq Zufairi bin Jafe, and our matrix 208324.
My name is Muhammad Uzai bin Muhammad Saber. My number metric is 205903.
My name is Abdullah Hanam bin Shamsuddin. My matrix number 207297.
And my name is Ahmad Abba bin Ayub and my matrix number is 208031.
So first, our outline for today's presentation is first, we're going to introduce the structure that we're going to present, then analysis of trusses, next analysis of frames, and finally analysis of machines, and follow up by the conclusions. Okay, so first, trusses. Trusses is basically an ensemble of beams that create a rigid structures. It must have two force members and arranged to act as a single object. Then we have trusses is a series of triangles that consist of tension and compression in each members. Next is frames. Frames is basically connected with joints, and each member can carry transverse of loads. It's not the same as trusses, and components that connect in such to serve as a structure. So structure refers to anything that is built or constructed with interconnected parts or at fixed locations. Lastly, machines. So machine is a mechanical structure that use the power to apply force and control movement to perform an actions. So it can be driven by various possible factors, like humans, natural force, and other factors. Modern machines are complex systems that consist of structural elements, mechanical, and control components.
Okay, for our truss analysis, we choose these structures that was an all-way rail bridge in Sungai Muda, across Sungai Muda, that have been used in British Imperial era of Malaya. So this is our free body diagram. As we see, there is no roller here, but there is roller here. So we draw our free body diagram, and we calculate the force of each member and the reaction of each member. First, we calculate the when we know that reaction 0 and reaction at y is 1. So we calculate from A. The x horizontal component is in equilibrium. All of the force in horizontal component is 0, so we equate that. We get the FAC is 10 kilonewton tension. Then we calculate FAB. We got in compression. Same goes to others force. We calculate one by one. For FBD, we calculate horizontal components equals in equilibriums, and we take this force, this what we call FAC force. Then we convert it to horizontal components to plus FBE plus FBD, and we got FBD, FBC. FBC is 0 member force. And then FDF horizontal components, and we got -10 in compression, -10 kilonewton. FDF, FDG, vertical, horizontal component in equilibrium. We got FDG is negative 14.14 kilonewton compression. FX, horizontal component equilibrium, we want to find FEG. So we got 20 kilonewton tension. FDE, we equilibrium, the vertical component, we got negative 10 kilonewton in compression. Then we find FFH, FFG, FFG first, by horizontal component in equilibrium. There we got FFH, vertical component in equilibrium. There we find FFI and FGH by using moment of equilibrium about G is 0. There we got FFI, FGH, both are in compressions. And lastly, we need to find FHK, FIJ. We find a moment at about I. There we got FHK and FIJ both in tension. Okay, that's all.
Okay, for the analysis of frames, so we use just a structure of frames. It is a typical folding chair where there is a 3 pins located in the E, D, and C. Assumptions was made for a 8 kg persons supported by the side of the frame shown. So here we can see that for each side, BCE, EDA, and DC, there is more than one force acting on the side. So we can say it is frame. Next slide. Next slide. So here is a free body diagram for and our calculations. So here we can see that W equal to 1/2 80 and times 9.81. So here we get 392.4 newtons. So we are gonna calculate the moment at A. The moment at A. So take the force and times it with the 360 minus 500 B equal to 0. Then we can assume that By equal to 282.5 Newton going upward. For the total force for vertical, it is equal to 0. So we can say that Ay plus 282.5 minus 392.4 equal to 0. Then we will get Ay equal to 109.9 Newton. And for the triangle EDC, we make a ratio here, which is A/B equal to 1/4. And here we get 200 minus A/B equal to 1/2. And we will get A equal to 66.7 millimeter and B equal to 262 millimeter. So for the moment at D, so total moment of D is 0. So 392.4 times 260 minus 200 Cy equal to 0. Then we will get Cy, which is 510 and 1 Newton. Next slide. So for the DC part, the total force of the vertical force is 0. So we can say that 510.1 minus 392.4 minus dy is equal to 0. So we will get dy is equal to 117.7 Newton going downwards. So for the last two piece frame, the total for vertical force is 0. So we can do dy plus 282.5 minus 510.1 equal to 0. So we will get dy, which is equal to 225.6 Newton. For the couple at for the moment at C, it's also equal to 0. So we can calculate EX, which is 282.5 times 200 minus 227.6 times 133 minus 267 EX equal to 0. So here we will get EX equal to 98.2 Newton going upward.
Okay, so for the next analysis of statics is going to be the analysis of machines. So we are using the nail clipper because this is the things that we can found in our household. So the assumption made was force exerted on the clipper handle is 2 pounds, which is from our human force, 2 pounds. So the force acting on the D, which is the D point on the free body ring over there is downward, and the force on the normal at A is upward. So the force acting on nail during manicure can be calculated. So we can count how many force acting on our nail when we use the nail clipper. So from the from the real nail clipper picture over there, we can create a free body diagram with approximate measurements of the nail clipper. Okay, so next slide. So we separate the parts of the machines. Firstly, the handle or the or the clipper in yellow color. So we can see that the we assume that FAY is downwards, DY upwards, and the force is 2 pounds, just as we assume. So using the moment at D, so we can count what is FAY. So we FAY after some calculation, we got 24 pounds downwards. And then we can count the dy using the vertical force, total vertical force, which is equal to 0. So we can count using dy minus f, which is the 2 pounds, and minus fay. We can get dy 26 lb upwards, and then we can count the force on the upper blade. So the upper blade consists of Fn, the normal force, the dy going downwards. So using the moment at B, we can calculate the Fn, the force, the normal force. So after some calculation, you can get the Fn, which is 31.2 pounds going upwards. Next. Next slide. All right. So Jose, last slide. The previous slide. Okay. All right. So actually, using the Fn, we can get the answer for our questions, which is how much the force acting on our nail. So using 2 pounds of force at the clipper, we can get the force acting on our nail is 31.2 pounds going upwards of the upper blade. So for the lower blades, it's going to be downwards. So that's all for machine analysis.
Okay, so the conclusions of today's presentation is the objective of our research based on the knowledge that we gain is trusses can be rigid if it designed in such a way that it does not greatly deform or collapse under a small load. Besides that, most of trusses come with the shape of triangles. There are a few methods that was used in trusses, and the method of joints or method of sections. Then there's the method of center of joints is the fastest and easiest to solve for all unknown faults in the trusses. Then there's method involves breaking of trusses down into individual sections and analyzing each sections as a separate rigid body. For frames and machines, usually contain multi-force member, and frames are designed to support loads and are usually stationary, fully constrained structures, while machines were designed to transmit or modify force and always contain moving part. So to analyze a machine, the machine need to dismember and follow the procedure as for frames. Then draw the free body diagrams for each multi-force member. So that's all from our group. Thank you.